Hey guys, Mr. Bowman here. Today's learning objective is in green and we are learning to calculate the mean in inverse normal distribution question. I've got a question already written in pink on the right and I've highlighted or underlined the key parts of information that we want to pull out from our question. So Mr. Bowman knows that the bottom 25%, so if we draw our normal distribution curve, the bottom 25% would be somewhere around there. So the bottom 25% of his year 10 class are going to score under 30. So we know that area relates to 30 points in the year 10 test. He also knows that the standard deviation is about 2.7 marks. So we're going to write up our standard deviation because that's 2.7 marks. And the question then asks us calculate the mean score. And the mean for us is always sitting in the middle there and we don't know what that is. Before we can calculate the mean, we need to know what the z value that relates to that 30 is. And then that gives us enough information to use our z formula to work backwards to find our mean. So to find the z formula, we're using the skills we learnt in our earlier video, where we're creating a standard normal distribution curve where the mean is 0 and the standard deviation is 1. We're then going to draw in roughly the same area from the previous question, so that's 0.25. And that means that z value there, we can then go through and solve that. So in the normal or the inverse normal function in our calculator, we're going to be dealing with a left tail, and that's because our data sits on the left-hand side of our graph. We're going to have an area of 0.25, and that's because the probability of a student in that area was 25%. We're going to have a standard deviation of 1, and we're going to have a mean of 0. And if you put that all into your calculator, you're going to get a z value of negative 0.6745, and I've rounded that to 4 dp. And I just want to emphasize that negative sign has a really important role. So we can't drop the negative sign or add a negative sign. We need to really pay attention to it, whether or not our z value is positive or negative. Now that we have a z function, I'm just going to change colors to an orange pen so we can see the next step. We need to substitute in all the values that we know into our formula. So we know the z value that's given us down there. So negative 0.6745, that is going to be equal to x from our original graph, which is 30, minus the mean, that is what we're trying to solve for, divided by the standard deviation from the original question. We then need to either use our algebra or the solver function in our graphics calculator to find out what that mean is going to be. So first step, let's move the divide by 2.7 over to the other side. And we do that by multiplying the other side. And that is going to be equal to 30 minus mu. We then want to move the mu to the other side. Mu is equal to, so mu plus 2.7 times negative 0.6745. That is going to be equal to 30. And we're then going to do our final step, move this part back to the other side as a negative. So that means 30 minus 2.7 times negative 0.6745. The two negative signs, they're going to cancel each other out, leaving a positive number. So 30 plus 2.7 times 0.6745 will be equal to our mean. So our mean is equal to 31.8 marks in that test, and I've rounded that to 1 dp. Hopefully this video helps you figure out how to calculate the mean of a normal distribution question. I just want to emphasize, if you can get to this step here, you don't need to do the algebra. The graphics calculator using the solver function will be able to calculate that mean for you. If you want me to make a video explaining how to calculate the mean using the solver function, please let me know and I'll get one of those up for us. Have a great day, and please pay attention for the finding the standard deviation video, which is going to be coming up next.